Good afternoon, everyone. My name is William Rizzo, and today I will be talking about abstracting abstracting resiliency for applications with CAPI and Linkerd. If this works. Yes. So that's my face, and somebody told me that I should say that that's the current face that I have on. So I don't know, it's a weird joke. So I'm a consulting architect at Mirantis. I'm a CNCF ambassador. And before today, I was a Linkerd ambassador. I think after the mistake that I made, my ambassadorship will be stripped. I also served in the release 132 Kubernetes team. And I am a member of the working group BIPOC, which I'll have one slide at the end to show you what it is, and the working group platforms. So the working group platforms and Linkerd ambassadorship, I think that's the link that you see, that you're going to see throughout these slides. Quick notice, we didn't hire many turtles nor any blue lobsters to run this presentation. Why do we care about resilience? So downtime is expensive. It matters a lot. And what I will show now is a different approach to using Linkerd and the features of Linkerd that one could think of initially. So we expect downtime. We expect failure. We want failure, and we want to understand how the failure happens, how it smells, and how long it lasts. And we have to always remember that when we maintain a platform, when we deliver a platform, that's a promise that we're making to our users. So that those SLI, SLOs, SLAs, they're all promises. So traditionally, the way we deal with resiliency is reducing the blast radius, stretching clusters across zones, across failure domains, let's call it failure domains, making disaster recovery plans, and eventually making highly available things, single things. So we have one node, let's make it 10. So we have less chances that something will fail. But we still have one cluster. We still have one cluster that is providing resiliency to the application, or the feeling of resiliency. So one step back, what is a platform? At least in terms of platform engineering, right? The DNA of a platform for us is a set of tools, of portals, or IDP, internal portals, documentation, interfaces, APIs, CLIs. All of these are good old things in platform engineering. What I'm trying to argue is that resiliency should be a capability of the platform. We should be able to provide resiliency as a service to develop, well, let's call them to the consumers of the platform, meaning that if a developer needs to deploy that next Spring Boot app, if it's in production, if it's going to go to production, there are certain capabilities that application must rely on. So one of those is the resiliency. So does anyone know this diagram? Has anyone has ever seen this diagram? Yeah? One? Okay. Two? Okay, two is better than nobody. I'll put myself just for good measure. So this is how we, in platform engineering, how we represent a platform, right? So we have on top, we have our product and application teams. At the bottom, so product and application teams is those that use the platform, those that consume the platform, developers, data analysts, also platform engineers, SREs, whatever. Underneath is those that build the platform. So the platform engineers will be sitting there. In the middle, the bottom part, the platform capabilities, is all those things that are components that build up the golden path that will be delivered upstream to the interfaces or initiated by the developers. I hope it was clear. If we lay over actors, as in names, we could look at it like this, more or less. As you can see, Linky, our friend, is on the right. Middle, it's the binding the services and applications together. We have on top for the portals, let's call that cyclone that you see. That's our baby, Cordant, our open source project for cluster API and provisioning. So we have Backstage, that's interfaced for our developers, but also the API of Cordant is the interface as well. So we are not exposing too much of the underlying the underlying components. So we are not exposing Kubernetes, but we are exposing APIs to something that manages Kubernetes. That's important for what I want to show you next. So how do we fit Linkerd in this thing? And again, so Linkerd, we know it as it's secure, reliable, and observable, right? But it's also intuitive, it's simple, and again, until a few minutes ago, I would say that statement was right. If somebody wakes me up at 3 o'clock in the morning, I know how that thing works. I know I can fix what's wrong with Linkerd, but apparently I don't know how it works very well. So one way that we have seen to bring resiliency into the platform is to avoid creating available single things, but one way that we can produce it is stretching a single thing, right? So the single thing is the cluster. We can stretch it across failure domains. That's one way to create resiliency. But we still have one component that is the failure, and that is the cluster itself, correct? So my control plane will fail, the application will fail. So my end user, in this case, is not the one on your left, but is the one on your right. The one that is consuming the application will see those 500s or those whatever errors. Another approach, so we can have multi-cluster approach. We can have our applications deployed in multiple clusters, and somehow we can have Linkerd that works very well in this case, synchronizing and providing the service to the users. In this case, our end user is reaching the application and is landing in failure domains or in clusters that he doesn't care. We are not exposing the cluster topology to the developer. We are exposing an endpoint. So does anybody know what happens when one of the clusters fail here in this case? Anybody there? Sorry? We don't have a failover here, right? So what we have, the application, if you look at the screen again, the application is deployed on all clusters. So we don't want a failover. I don't want my application, my service to fail over to another cluster. I want my clusters always to serve my users. So I have 3 clusters. Why do I have to round robin across the cluster? I want to serve from all clusters the same application. So if one cluster fails, or if one endpoint fails, what's going to happen to the request? I get 500s, right? So that's the problem with multi-cluster. It's a very good deployment topology, but the end user will eventually hit 500 errors. They will get it. And depending what applications we'll deal with, it's okay to get 1 or 2, but there are certain conditions that those downtimes are not acceptable. So how we can fix this with Linkerd is a different approach. When we have federated services, we have the same condition. We have 3 failure domains and 3 completely different clusters, 3 different zones, 3 different providers. One might be on-prem with our good old K0S, of course. We have cluster API provisioned in those clusters, of course. We have Linkerd, again, deployed in those clusters. But at this time, now you can see there is Linky over there. Linky is representing a federated service version of the services that are deployed anyway in all those clusters. So in this situation, the services the federated service will communicate with the services behind in all cluster. There is no way to draw exactly how that works. I mean, there is a way to draw it, but not draw it cleanly how it works, of course, for me. So I would like to be clean. But we would have a line through the Linkerd box into each one of those applications. So that's the main point. Now, when our user connect to the federated service on Linkerd and one of the clusters fail, what is going to happen now? Before we had 500s. What's going to happen now? Yes? Well, it's not going to send it. So so the federated, okay, that blue box there is the federated service, right? So we have service A1, service A2, service A3, right? 3 times. So if my user hit that service, and one of the clusters is down, it's not going to get a 500. It's going to hit the clusters that are live, the services that are live, right? So we have over there a happy user. I needed to put his photo, of course. So in this condition, so why this is good in platform engineering? Why, going back to platform engineering, we want the platform to provide this underlying topology to the user without exposing the cluster topology. So we don't want the user to know that he's running on 3 different Kubernetes engines, 3 different providers. We want the user, so maybe 12 or 18 months ago, our idea in platform engineering is that the users shouldn't be exposed to Kubernetes. We still believe that. The developers shouldn't be exposed to Kubernetes. We still believe that. So those guys over there, the users over there, and this guy over here that is smiling, they should not know, they should not be exposed to the cluster topology. But what we also believe, we improve that statement now, and we say that those guys over there at the end, the users or the machinery that is deploying on Kubernetes, we want them to know that that application, that workload, we will deploy on Kubernetes so that they can optimize their work, but we don't want them to take care of the Kubernetes topology. So that's very important, so that we optimize. And then when we optimize, we platform engineers, we can do something, begin to do something, things that are fancy, because we know that our developers will deploy optimally for Kubernetes. We can create things like automatically creating federated services on Linkerd for them on multiple clusters, or spinning off preview environments with Linkerd and with federated services enabled, so that we can test also our platform while they're testing their applications. So we have several ways to play around with the same objects. And
are you presenting from your laptop?
I'm sorry?
Are you presenting from your laptop?
Yes, something wrong?
A Slack notification.
Oh, I do? Oh, I'm sorry. I'm sorry. Fortunately, it wasn't something bad. Okay. So this is the argument, right? We don't want the users to be exposed to the cluster topology, to the concept of clusters. We don't want them to be exposed to the service mesh, but we want to use the service mesh as, we want to increase the layer of resiliency of our platform using things that are already there, like Linkerd. This was the important part. The other important part is that we have a Black, Indigenous, and People of Color program, and we are looking for mentors. Mentors that look like me, or mentors that look like, also not like me. So of all colors, but specifically for Black, Indigenous, and People of Color. So if you would mind to sign up and to put your name up for mentorship, we're very happy. We take all your data and we just drop a virus in your phone, send very quickly. And that was all. Thank you very much. Do you have questions? Do you have time for questions, Flynn? No? No questions? Yes?
Sorry, I don't know Linkerd at all, so maybe you can tell a bit about where is Linkerd running in this instance, and what are federated services?
Oh, okay.
Yeah.
I didn't say that. Okay, Linkerd is a service mesh. That was a joke. That was a joke. That was a joke. It was a joke. So Linkerd in this case is running on each one of the clusters, of course. Okay. Yeah, Linkerd is running on each one of the clusters. We would create a multi-cluster topology, and on top of it, we would create the federated services. The federated services is the Linkerd will federate the services that we deploy on each cluster. We'll federate it across the other clusters. But I feel there is more into it for you.
I don't know what federation you mean. Like magical things, like
Actually,
when you.
can I interrupt you on it?
Oh, sorry.
Your timing is beautiful because Alex is up next to talk about federated services.
Oh, there you go.
Okay. So the last question then is where the Linkerd is running on all the 3 clusters in this setup.
Yes.
But then is there a load balancer in front of it? Or something
Yes.
like that?
Yes.
And where is that running? Somewhere else? Or
It's outside the clusters.
so, but where? Because we're all
It can be.
environment, so.
Well, it depends where are the clusters, right? Yeah. You could have a situation when you have 3 load balancers because you might have an on-prem cluster and 2 in-cloud clusters. So you would have different entry points for those clusters, and you could have a global load balancer on-prem and on cloud.
Okay, so that's not something Linkerd does, but that's another
No,
part of this
Linkerd, no,
infrastructure.
it's not Ingress. No.
Okay.
Yeah,
Okay.
Thank you. Any more questions? Well, thank you.